G'day, mate. Ever looked up at the night sky and felt a sense of wonder? It's a vast, dark canvas, isn't it? Dotted with countless stars and distant galaxies. For thousands of years, we've stared into that abyss, asking the big questions. Where did it all come from? What is our place in it? We've made incredible progress, mapping the stars and understanding the laws of physics that govern everything from a falling apple to the orbit of planets. But there's a colossal secret hidden in plain sight. A mystery so profound it challenges everything we thought we knew about the universe. It's a force that makes up nearly 70% of everything that exists, yet we can't see it, touch it, or directly measure it. This invisible enigma is called dark energy. It's not just some quirky cosmic footnote. It's the dominant force shaping the ultimate destiny of our universe. To really get our heads around dark energy, we need to take a step back and look at the bigger picture. For most of human history, we assumed the universe was static and eternal. But in the 1920s, an astronomer named Edwin Hubble made a revolutionary discovery. He observed that distant galaxies were all moving away from us, and the further away a galaxy was, the faster it was receding. This was the first concrete evidence that our universe was not static at all. It was expanding. Hubble's discovery was like finding out that the dots on the surface of an inflating balloon are all moving away from each other. Then, in 1998, everything changed. Two separate teams of astronomers were studying distant supernovae, trying to precisely measure the rate of the universe's expansion. Everyone expected to find that the expansion was slowing down due to gravity, but they found the exact opposite. The expansion was accelerating. So how do we begin to explain this bizarre cosmic push? Well, our first suspect has been around for over a century. It's an idea that came from the mind of Albert Einstein himself. When Einstein first developed his theory of general relativity, his equations suggested the universe should either be expanding or contracting. To fix this, he added a mathematical fudge factor to his equations, a term he called the cosmological constant. When Edwin Hubble later proved the universe was, in fact, expanding, Einstein famously abandoned his cosmological constant, calling it his biggest blunder. But history has a funny way of coming back around. When astronomers discovered the universe's accelerating expansion in 1998, suddenly Einstein's old idea didn't look like a blunder at all. The problem is, while the idea works beautifully in theory, it comes with a massive headache. When our best theories of particle physics try to predict the amount of this vacuum energy, they come up with a number that is staggeringly, mind-bogglingly wrong. The predicted value is about 10 to the power of 120 times larger than what we actually observe in the universe. It is, without a doubt, the worst theoretical prediction in the history of physics. Because the cosmological constant theory is so problematic, scientists have been exploring other possibilities. What if dark energy isn't a constant property of space at all? What if it's something more dynamic, a new kind of energy field that fills the entire universe? This alternative idea is known as quintessence. The name comes from the ancient Greek concept of a fifth element, a pure substance that made up the heavens. One of the most extreme versions of a dynamic dark energy leads to a wild scenario known as the Big Rip. In this future, the strength of the dark energy field doesn't just stay constant or grow slowly. It increases exponentially over time. If this were to happen, the repulsive force would become so powerful that it would eventually overcome all other forces of nature. First, it would tear apart clusters of galaxies. Then, it would overcome the gravity holding individual galaxies together. In the final frantic moments, it would be strong enough to pull apart star systems, planets, and even the atoms that make up our bodies. The fabric of space-time itself would be torn asunder. It's a terrifying thought, but one that can't be ruled out just yet. Okay, so here's where things get really interesting. We've got two main suspects when it comes to what's powering dark energy. So how do we figure out which one is right? The answer, believe it or not, is all about making these insanely precise measurements of how the universe has been expanding over like billions of years. That's the main mission for some of the biggest astronomy projects ever. I'm talking about the Dark Energy Survey, the Euclid Space Telescope from the European Space Agency, and NASA's upcoming Nancy Grace Roman Space Telescope. These projects are mapping the positions and shapes of like hundreds of millions, sometimes billions, of galaxies across the cosmos. These surveys aren't just doing one thing either. One technique is basically continuing the work that led to the original discovery, finding and analyzing thousands more distant supernovae to chart expansion at different times in history. Then there's weak gravitational lensing. Einstein showed that gravity can bend and distort the light from far-off galaxies as it travels to us. So here's the deal. We figured out that the universe isn't just expanding, it's actually picking up speed. This isn't some chill, slow-motion thing. Nope, it's a relentless full-throttle acceleration. Picture yourself on a raft floating in the middle of a massive ocean. At first, there are other rafts nearby, easy to see. But then, imagine the ocean itself starts stretching, and suddenly, every raft is being pulled away from every other raft faster and faster. Now here's where things get kind of wild. With this accelerating expansion, there's a weird invisible boundary forming around us, a point of no return called the cosmic event horizon. When a galaxy crosses this horizon, it's lost to us forever. It just disappears from our observable universe. Our descendants, if they still exist, will look out from our Milky galaxy into an abyss of absolute blackness. The majestic night sky we know today, filled with the light of 100 billion galaxies, will be gone. All that will remain will be isolated island galaxies, like our own local group, separated by unimaginable voids of expanding space that can never be crossed. So, while dark energy is pushing galaxies apart on the largest scales, you might wonder, what effect does it have on the structures within them? Well, for the foreseeable future, the answer is virtually none. But the long-term story for our galactic island is really one of slow, graceful decay. The era of star formation won't last forever. The brilliant, massive blue stars will be the first to go, living fast and dying young in spectacular supernova explosions. After trillions of a trillion years, even the red dwarfs will finally exhaust their fuel and fade into cold, dark stellar remnants known as black dwarfs. The galaxy will become a graveyard, a ghostly swirl of black holes, neutron stars, and cold, dead stars. And then, over even more mind-bogglingly vast periods, even these black holes will evaporate through a process known as Hawking radiation. The universe will be left with nothing but a diffuse, incredibly cold bath of stray photons and elementary particles. This vision of a cold, lonely future raises a monumental question. What does this mean for life and intelligence in the universe? For any civilization, no matter how advanced, the accelerating expansion presents the ultimate challenge: cosmic isolation. Those distant galaxies are not just far away, they are becoming fundamentally unreachable. The journey to them isn't just long, it's impossible. Faced with such a daunting future, you gotta wonder, could an incredibly advanced civilization actually fight back? Could they, turn the very agent of their isolation into a source of power? This brings us to one of the most speculative but honestly most tantalizing ideas in all of science: harnessing dark energy itself. But some folks have proposed a hypothetical Type 4 civilization, one that could harness the energy of the entire universe. In a cosmos dominated by dark energy, that would mean tapping into the energy of the expanding vacuum itself. If harnessing dark energy turns out to be impossible, well, a totally different, and honestly way more desperate strategy might have to be considered. What if a civilization's only hope for a bigger future is to physically leave its home galaxy? That would mean embarking on the most ambitious journey anyone's ever thought up, building intergalactic arcs to travel to other galaxy clusters before the accelerating expansion carries them forever out of reach. Ultimately, the relentless expansion driven by dark energy might, force a civilization to look inward and fundamentally redefine what it means to be alive. An advanced civilization might have to move away from its biological origins entirely, shifting its consciousness into more durable and energy-efficient forms. Imagine a collective consciousness, the minds of trillions of beings, stored in vast, crystalline computational networks, maybe kilometers across, just floating in the frozen void. Dark energy, for all its mystery and unsettling implications, presents humanity with an incredible opportunity. It represents the absolute frontier of our knowledge, a vast, uncharted territory in our understanding of the cosmos. Solving the mystery of dark energy will not just be about adding a new footnote to our textbooks. It will likely require a complete overhaul of our understanding of space, time, and gravity, sparking a scientific revolution as profound as any in history. So where does this leave us? We stand at a pretty remarkable point in cosmic history, armed with the knowledge that our universe is not just expanding but accelerating towards a future that's colder, darker, and lonelier than we ever imagined. As we look up at the night sky, we're not just seeing the ghosts of distant stars and galaxies, but a glimpse of our own destiny. The universe is a far stranger, grander, and more mysterious place than we ever thought, and the greatest adventures in understanding it still lie ahead of us. The quest to understand dark energy is a quest to understand our home, our future, and our ultimate place within the cosmic story. For now, the future of civilization in a universe powered by dark energy remains an open question, a blank page just waiting to be written. The cosmos has thrown down the ultimate challenge, and whether life can rise to meet it is a story that will unfold over billions, maybe even trillions of years. The journey has just begun.